this one is moving, becomes a 0 because we are saying it is from right speed, so we don't have it. So at this point, our u is going to be given as 0. We are having our acceleration of 5 meters per second squared. Even the u at the base is also 0 meters per second. This is u at f, and this is acceleration at f. This is the r, that is at the base. So we are going to look at here they're saying the intersection occurs where the two vehicles meet. For these two vehicles to meet, what we are supposed to do is for meeting. For the two vehicles to meet, the distance at A plus the distance at B of B is equal to what? 20. The distance of A and the distance of B is equal to 20 meters. But when you look at on the given condition, what we are having so far in our summary, we will realize that we don't have the time, but it is necessary for us to get the time. You know, when something is moving, we always move to get the time. That is why I am going to look at, first of all, the three equations of motion. And when you look at the three equations of motion, we always look at the first equation that gives us the v equals to u plus a1 plus at. We look at the second one, s, which is equal to u plus r at squared. And then you look at the third one, which is v squared, u squared plus 2ns. I am going to look at out of the three equations there, which equation do my summary lies. Look at the first one. In the first equation, we realize that we have the final velocity and we have the initial velocity and the acceleration, which is already there summarized. But in our summary stage, we are looking at the distance, meaning that the first equation does not qualify. In the second equation, the distance we are looking for, it is in it. The u, we already have it, we are looking for t. Acceleration, we have it, and we are looking for t. And in the third equation, we don't have the final velocity, but I have the initial velocity in each case, that is from A and B. And then also we have the acceleration and the distance. Meaning that when you look at it in the third equation, you realize that even that one here will not qualify. We are going to look at the second equation. That is the, you can say, using S equals to U T plus R F X squared. So at point A, I am going to consider those, meaning that we are going to have S at A, which is equal to our U, which is 0, 0 times 3, plus R of A, our A, which is a Q, times our T, which we don't know that is T squared. So S at A, this one already will give us a 0, and then here the 2 and the 2 will cancel, meaning I will have the S and A as zero as the T squared. That is for that. At point B, we also look at S at B. S at B, even our initial velocity is 0, so this is U times T plus R times our acceleration there is 5 times T squared. So you also realize that our U at our S at B, this part remains 0, and then here we are going to consider 2 divided by 5 divided by 2, which is the same as 2.5 0, 2.5 T squared, and then we are going to put them back in our expression for the meeting point. I am going to add S, we are going to say at S at A plus S at B, which is given by 20. We are doing this to get the value of the time taken for those two vehicles to meet at a certain point from their respective distances. So this is the t squared plus 2.5 t squared, which is equal to 20. Look at the time. This is going to give us 3.5 if I add equals to 20. Can divide by 3.5, divide by 3.5. Look at this. When you divide 20, 20, when you add 20, when you add 20 divided by 3.5, you realize that our t squared is going to be equal to 5.714 times 743, meaning that our t is going to be equal by finding the square root of 5.7143. We always say in pure mathematics that whenever we are getting a square root of a number, it's always given by a plus or a minus. So if I come and get the square root of the answer, you realize that this is going to be given by a plus or a minus 2.3905 seconds. But I will always conclude the value of t to be a positive one, be a positive number that is given in seconds. But here in the part of the question they are saying, investigate the point on the road where the particle would meet from point A, which means they are not interested in time, but they are interested in the distance from point A. The distance from point A, I'm going to get it by just substituting my value of time here. I'm going to say the distance from point A. The distance from point A, to say that our S was equal to t, our S at A was equal to t squared, meaning that our S at A is going to be our t, which is 2.3905, but this is what? Squared. Got it somewhere there as the 5.714 is not given in the what? That is given in terms of meters. So that is how our part B of the question was supposed to be done. Part C, they are saying number 1, investigate the course that must be set by Q to pass as close as possible to P, and the shortest distance as follows. So from that topic, you realize that we are now moving into another topic, that is the vector mechanics. Under vector mechanics, there are different things we are supposed to consider, and some of them they are somehow related to the vector to look at in pure mathematics. But here you realize that there are also other different things we are supposed to consider that may not be applicable in the paper 1, that is under pure mathematics. So what we are going to look at here, I beg you to follow it very well, and then we understand what is done and what is not supposed to be considered. So in that part of the question, it says that meanwhile, to rescue motorboats P and Q began moving on the lake. Boat P travels at a constant speed of 20 kilometers per hour on a bearing of 060 degrees. While boat Q travels at a constant speed of 10 kilometers per hour. At 2:00 p.m., the operator on a boat Q observed that boat P is 4 kilometers US of boat Q. We are going to look at them in the last question. So they are saying the intention of the operator on Q is to pass as close as possible to P. That's why in the first part they are saying investigate the cause that must be set by what Q to pass as close to P and the shortest distance possible. So the cause we are looking at here, we are looking at the angle where the two vehicles will have to meet, and the distance also we are going to get them from the same point. And then number two, they are saying we help the operator to know the time when the rescue will take place. Also, we are going to look at the time that is between the two. Let us look at some of the summary here. So in our summary, I am going to represent this on a diagram that if I'm dealing with a pit, we look at this, that if this one is moving at a distance, they are saying that the angle is 60 degrees, and its velocity is given by 20 kilometers per hour, meaning that the velocity of p is going to be given by, you can say, when I go ahead and then I resolve this, let me say I resolve this one and that one there. This one is always resolving vertically is always 20 cos of 60, and horizontally is 20 sine of 60. All these ones are given in degrees, meaning that vertically, that is on vertically, we are going to have, this is 20 sine 60, and then this is 20 cos of 60, 20 cos of 60 degrees with the kilometer. With kilometer yeah, diagram what? 20 sine, okay, I'm sorry. This is 120 sine 60, and then I'm taking this to 20 cos of 60, meaning that this is the cos of 60 degrees, and then this is the sine of 60 degrees. That is for the cos of P. Q. Q here, we are not given the angle. I will have only my angle here. And then we also have our value of the velocity that was given by 10 kilometers per hour. That's if I generate this. Once we are going to be moving at this is 10 sine of theta, and then this is 10 cos of theta. So the velocity of Q will be given by 10 cos of the angle, which we don't know, and 10 sine of the angle, which is we don't know. This one will also be given as a kilometer per hour. So to get the possible, they are saying that the intention of the operator on Q to pass as possible to Q. So we are going to say for Q to pass as close as possible fast as close as possible to P. At that point, we have to look at the velocity of Q. The dot product of the two should be given by the velocity of the Q relative to P, which is going to be given by 0. But you realize that we don't have the V Q of P. But in a simple way, this one can be obtained by getting the velocity of Q minus getting the velocity of P. That is in terms of the vector form. Meaning, I will have the 10, which is the velocity of Q, the 10 cos of theta, and the 10 sine of theta, minus the one for P, that was 20 cos of 60 degrees, and 20 sine of 60 degrees. Meaning that our Q, velocity of P, will be given by, you subtract what is on the arc alone and what is down alone. This is cos theta minus 20 cos of 60. And then the down part becomes 10 sine of theta minus 20 sine of 60 degrees. So this is now our velocity of Q with respect to P. So we are going to use the expression we have got here as VQ of Q VP, a dot product of the two, to give us the 0. VQ, we have 10 sine, 10 cos of theta, and 10 sine of theta. We get the dot product of this is 10 cos theta minus, get the value of the cos 60 multiplied by 20 times cos 60, which is 10 here. Then we also have minus 10 sine theta, which is minus 20 sine 60, 20 sine of 60. Here is the 17.3 to 0.1, 0.5, then equals to 0. So meaning we are going to apply the dot product, whereby we said under dot product, without them basing on the part. The upper part we multiply with the upper part, and the downer part we multiply with the downer part. That's what we are looking at. So I'm going to dot this. I'm going to make sure that I multiply the upper part with all the upper part, and then we add it to the downer. We add it to the downer part. So I'm going to start with the first one. If I multiply the 10 cos times all of the upper part, you realize that the 10 cos, if I multiply by the 10 cos, 10 times 10 will give me 100. And then cos times cos will give me cos squared theta. Go to another one. 10 times that, you have the 100 cos of the angle, and then plus, because we are done with the upper part, we come to the downer part, plus the downer part, which is also 100 sine square. Then we come and deal with this, which is the case of that one. There will be, can say, see, 10 times 10, which is 1, and say minus 173 sine theta equals to 0. I've just added it to that. So I'm going to collect like term. In the right collection of like term, I'm going to be targeting the trigonometric identities. Like when you look at where we are seeing 100 cos squared and 100 sine squared, you realize that what will act as the common factor in those ones there will be 100. So what I'm going to do, I'm going to say that if I pull out the 100 here, You have the cos squared theta plus the sine squared theta. That is when I deal with this and that. So which means that we are going to have what is remaining as 100 cos theta. That is for the first part. Then minus 173 sine theta, which is equals to 0. But we all know very well that under trigonometry, we say that whenever we see sine squared plus cos squared or cos squared plus sine squared, we always equate it to 1. So meaning that when you look at what is multiplying 100, that is already equivalent to 1. Meaning here I'm going to remain with only 1. I'm only going to remain with the 100 because that part is already 1 minus 100 cos theta minus 173 sine of theta equals to 0. Collect like term. The like term I'm going to collect, I'll make sure that I remove the negative from the cos and the sine, maybe by taking them that side. So meaning I'm going to have something of this kind, which is going to be equals to this one. When it goes that side, becomes 100 cos theta plus 173 sine of what? 173 sine of the angle. I said before that we have to first look at the angle, which will act as the cos that must be set by Q to pass as close as possible as the P. Let us see how we are going to have that angle. When you look at in the expression we are having in the last part, you realize that that expression can be obtained in different ways. All the values of the angle can be obtained in different ways. When you try to make a recall on the part of trigonometry, you will discover that some of these expressions can either be solved using a T formula, or I can use the ARA, or I can use the ARA formula, depending on the one which can be easily used to solve. So, in my opinion, in the last part, I'm going to take the cos theta, which is given by 173 sine of theta. We have said that it is equals to 100. But in my focus, I will have to first aim at solving this. I will have to first aim at solving this part. So I'm going to solve this part using the ARA. I'm going to solve it using the ARA formula. But I'm going to make a comparison that if I have this 100 as A, maybe as with the cos, we are now in a derivative of trigonometry, with the B and a sine. We say that whenever it starts with a cos, we will have our R, because it has started with a cos, meaning that this is going to be a cos. Then with the angle we are looking for, we can say it is the alpha plus the theta, which is given as that. This is supposed to be a minus because we are dealing with a cos. So we are going to find this. We are going to find this value. I'm going to start from this side, which will be the comparison that if I want to get the value of R, this is given by the square root of A squared plus B squared, whereby our A and our B is going to be got by the comparison. I'm going to compare the coefficients of cos, and also I compare the coefficients of I also compare the coefficients of sine, meaning that our A is the same as 100 and our B is the same as 173. Then our R will now be got by having this is 100 squared plus 173 squared. Get the value of R here. The value of R here, I'm going to press them at 1. That's 100 squared plus 173 squared. Then we find the square root of the answer. Our error here is the same as 1. Can say 199 point that. I'm going to round off 199 point that. We are going to make it to be the 200 units. That is for R. And then for the angle, that is alpha, given, we say that it is got by the tan inverse of B divided by A. So this is the tan inverse. We said our B is the same as 173. If I compare, divide by 100. So we get 173 divided by 100. The second shift, the tan of the answer. Our alpha, I will also round off this to make it in the form of 60 degrees. Meaning that all of this part is now being substituted by this. So it means instead of putting this, I am going to put all of this one here to be here. So I'm going to say where there's 100 cos theta plus 173 sin theta. I replace it with r cos of alpha minus theta equals to, we say that this is equals to 100. But our r here is the same as 200 cos of alpha, which is 60, minus the theta equals to 100 degrees. So this is going to be, we can divide by 200. By 200, we are going to have this minus theta, which is equals to 0.5. Get the value of theta. This minus theta is going to be the cos inverse of 0.5. Cos inverse of 0.5. This is it. 60. That is the 60 degrees. Meaning 60 degrees, you have, when I try to collect like term, you have the negative theta being equals to what? Being equals to, this one goes there as 0 degrees. So our angle the same as the 0 degrees. But that one there will not be our next part. The another part may be if someone starts by considering this one here first. Whenever you realize that if I start by considering this one here first, even what is here will change. Meaning that what we are going to consider for that part, this part here will no longer act as a positive. Someone may end up getting what is the different from what is done here. So we look at we are given, we add the velocity of P and we have the velocity of, we add the velocity of Q. Our P was the 20 sine of 60 and this was 20 cos of 60. So VP, this is the so if the theta is the first, meaning here we are going to have the 60 step, then we correct this to be 101. We correct this to be 120. So meaning here we are going to have 120 degrees. So if that is 120 degrees, we can now have the velocities at each point. At this point, we said this was 10. That is if you multiply 20 sine of 60. Say this is 17.3. 17.32. You can say 0. Then down here 20 cos 60. This is 10. That is at P. The velocity of Q, said it was 10. We are going to go with the cos. The angle we have got is 120. Then this is 10. Sine of the angle we have got, which is also 120. So we at a Q will be 10 of the cos of 120, which is negative 5. Then that is a 10 sine of 120, which is the 8.660. You can say 3. All of them are given in kilometers per hour. So now we can go back. Then we look at, since the question was asking for, the question here was asking for, they have said that we should investigate the cause that must be set by both Q to pass as close as possible to P and the shortest distance. I said before that at this point the cause cannot mean angle. So we are going to look at the shortest distance. The shortest distance, they have told us before that that the operator on the boat Q observes that boat P is 4 kilometers due west of boat Q. So if I have boat P here, it will be on the west of boat. It will be on the west of boat Q. So if this is boat Q, this is our boat P. The distance between them here is the same as 4 kilo, same as 4 kilometers. Which means if I try to look at the relative velocity of this Q to P, you realize that the velocity of Q relative to P, based on this, we are given the horizontal distance, that is 4, but we don't have the vertical. We don't have the vertical distance when you look at that part. So this one given in terms of kilometers. Then you can now look at the shortest distance, whereby you can also call it the minimum. You can also call it the minimum distance. But for the case of the minimum distance, you're going to look at its velocity and the given. We're going to look at the velocity, which is at Q and P. We also look at we cross it. I will cross it with the Q, which is relative to P. But you realize that we don't have. We only calculated for this, but we don't have it. Remember, we said that it's the same as the velocity at Q minus the velocity at what? The velocity at P. So we are going to get the velocity at Q and the velocity at P, which is the negative 5. Then the 8.6603 minus the big space. You'll have the shortest distance, which is the minimum distance. Said it is V. The Q VP, said is the same as the VQ minus the V at P. So our VQ was negative 5, then 8.6603 minus the one of P, which is 17.320, then this is the time at P. This will give us the negative 5 minus 17.320. So this is negative 2, negative 2.32. Then the downer part will be negative 2.6603. Then I'm going to get the magnitude of the cross product of the two to get the distance. Sorry? Cos 60. Then this is the sine. Sine 60 also. So meaning at this point, you'll have, you can correct 20 cos 60, which will remain what was up. And then this one will be what was down. 20 sine of 60. Given as 17.320. So I'm going to change it here. Here it's going to be 10 and 17.320, which means that's going to change this. This will be giving us negative 15. Then the downer part will give us negative 9 point. Let me see. That is 8.66. 8.6603 minus 17.320. That's negative 8.6591. So meaning we'll be having our shortest distance or the minimum distance, which will be given by the negative 15 and negative 8.6591. This say that we are dealing with a cross, so meaning that we are going to have multiply as the next one is 4, 0. So this, if you cross it direct, you will have 15 10 times 0, that is 8.6. 8.6591 times 4. What do you get? 34. So this one here becomes our shortest distance. Will be 34 by 6 kilometers. Then you look at the time of collision. Time that was given by saying the operator. So that is the time. The time when the rescue will take place. So this time we are going to obtain them by, since all these bodies were moving in we are moving in the horizontal. I will take all the points on the horizontal from QRP and V and QVP. When you look at in our QRP, we add 4 0, and our QV we add 15, which was negative, and 8.65991. The reason why we are taking this, because when you look at the upper part, is the same as the distance, but this is the same as the speed. And we always say that whenever we are dealing with the time, we get the distance divided by what? The distance divided by the speed. But the distance and the speed, I'm going to take what is on the horizontal only, because these bodies were not moving on the vertical. So I'm going to take the 4, then with the 15. The 15 I'm going to take is also going to be in terms of positive, not a negative. 0.2667. In terms of hours, I multiply by 60. So which is 16 hours. That is approximate. But here they are saying that it was at 2 p.m., which means we have to look at the time when they have rescued them from 2 p.m., meaning that we are going to have the time here, which is now going to be given by 2:00 p.m. Plus 16. In fact, this time is supposed to be in minutes, not in this, because we have multiplied by 60. So minute. So this is 2:16 p.m. This is the rescue time for that Roman 2 of part C. So that is specifically how the number was simply supposed to be done. When you look at in the next part, we are also having another item that was still coming from the same paper. I think it was JEBBU.